Okay, so we're back in here. We have JavaScript pulled up. What I want to talk about next is, once again, another principle that transcends all programming languages. And this is the concept of types. Now, when dealing with data in any programming language, certain types of information is processed differently, read differently by the computer. So for instance, a string of text is not going to be read the same way as a number. And the way you interact with numbers is different than strings of text. What does that mean? Okay, so let's just declare some variables. I'm going to call this one string. I'm going to put in, well, you know what? We'll just toss in there hello world. And then let's do another one called integer. We're going to call that, I'm just going to say 1. So what's the difference here? So let me put it to you like this. If I took this, put it back in here, and I took off these quotes here, and then tried to run this program, it's going to break. It's breaking for, well, it saw this and it's like, what the heck's going on? Because these quotes are here, this is what's called a string. When you take those quotes away, the computer reads it differently. It actually is looking for a variable called hello, and hello's doesn't actually exist. It's nowhere in here. And then it's also looking for a variable called world, and then it's this exclamation mark is actually used as a negating sort of property that you can use on variables. All this is to say the computer has no idea what you're trying to say here unless you put quotes on there. Then if you run that, it's going to print out hello world. And we can use single quotes, we can use double quotes as well. Same thing, really. Same deal. But here's what I mean by a string, because I remember when I first started programming, this concept of a string kind of threw me for a loop because, well, for instance, if I did this, so here's the deal. This is not the same thing as this. I know that at a glance this looks like the same thing, but the computer is going to process these two things in different ways. This 1 is interacted differently when it's got these quotes around it than when it's just a normal number. And let me put that in perspective. We can jump into Python here. So let's do now, if the computer read both of these as a number, when I added them together, it should just output 2. But I can tell you right now it's not. Here's what's going to happen. It's going to break. It's unsupported operand types for addition, int and string. So if we did do that, and then what's going to happen here? 100. So it basically just added these two things together. It stuck them together, concatenated them. It's appended these two zeros to this 1. And that's how strings tend to interact with each other when you multiply them. Excuse me, not multiply. When you add them together. And there's another common number type. It's called a float. I probably should do this just in case that's a protected variable inside of Python. But if I do this, if I add a decimal point here, oops, sorry, that's a equal sign. Boom. And that's how math works in general too, right? 1 plus 1.0, 2.0. So in programming, and this is, again, every single language has strings, they have some concept of a float, and they have integers. Float is just a weird way of saying a decimal. It's a floating point number. And Again, every single language has something like this. Now, JavaScript is a tad bit different in its approach to that, but it's probably better just to show you this. So in every language, there's a way that you can get the type of something. So 1.0. In JavaScript, it's called type of. And we'll just do float. It comes back as a number, and JavaScript puts all numbers under this umbrella term as a number, but that being said, there's still a concept of a float in JavaScript. So in Python, it will just do this. Actually, in Python, it's just type. And then we can just do 1.0. We can just toss 1.0 right inside of this type, and it'll work the same way. Class float. See that? And then if I do this, class int. And then if I do this, class string, str. Ruby, same deal. We'll just do this. Now in Ruby, it's got a different word for it, but same principle here. So if I do one.class, that's just a way of finding the type in Ruby. They just call them classes. String. Integer. Float. Look at that. And that's another thing to keep in mind. A lot of these concepts, like I've been saying, they transcend the programming language, but they often are called different things arbitrarily. And again, all of this is sort of just a way of thinking. You know, somebody at the end of the day, these are all these languages were written by humans, and so they're going to have these discrepancies in words and meanings, these sort of semantic differences. So, you know, a class in Ruby is basically just a type, but they call it a class. These are just things you have to keep in mind. You know, it's these just weird human discrepancies. Good old semicolon. You know, fun fact, I think one of the space shuttles actually exploded because of a missing semicolon. Good stuff, huh? Look at that integer. So all this is to say that there are this concept of types, and these are not all the types there are. There's a tremendous amount of types out there. Some of them get a lot more abstract, but these are the main three types. And in some languages, they have different kinds of numbers. They get a little bit more specific, and part of that is because there are some issues with just using floats. I think especially when it comes to databases, that when you're using money, there's a sort of an issue with how the computer reads floats. It's not entirely accurate. That gets a little bit more complex into the sort of math of things. But all this is to say, types is a constant sort of paradigm in all programming languages. And as I'm coding, I constantly keep this in mind. I'm constantly aware of the different types of the variables I'm using so that I can interact with them in the right way. So, hope you learned something. Thank you for watching.